Recording in progress. Nice. Okay. Get big. There it is. Okay. So I have this. What happened on my screen here? I'm assuming you guys can still see the slide at home on the screen. Because okay, beautiful. Because here on my screen in the classroom is giving me a PowerPoint thing, and I can't see you guys. Not that I could see you anyway, because you've all turned your cameras off. All right, current electricity. So there's a couple of different. Like I said, the first two slides will just deal with vocab. The battery, right? The battery is the supply of energy. Supply of energy. Okay. Obviously, we can get our energy supply from things other than a battery. All right, but for our sake, when we refer to it in this class, when we refer to our power supply, our energy supply, we're going to use the word battery most of the time. Okay. With a battery, you have a positive and a negative end of the battery, right? We've all seen that, I'm assuming, right? So the positive terminal is considered high potential energy, and the negative terminal on your battery is considered low potential energy. So when you set up your circuit and the electricity flows through your circuit and you turn on the flashlight or the laptop's using your battery or whatever it is, your phone running on the battery, in the circuit, when the electricity flows through the device, it goes from the positive through the wires, through the device to the negative, right? Energy falls from high potential, falls in quotes, from high potential to low potential, right? Just like gravitational potential, right? I take my pen, it has high gravitational potential because I lifted it up high, and when I let it move, it falls to the low gravitational potential, right? In the process moving. And the same thing's happening with the charges in the electrical energy. They're falling from the high potential, to the low potential as they move through the circuit. Okay. We can increase that potential, it says, by connecting the series, right? We can increase the battery. So you can, right? That's how in, some, right? In things that have more than one battery, right? You always put them in opposite, right? If they're next to each other in the remote control or something, right? They go in opposite. So positive's facing up on the first battery, and then it's facing down on the next battery, and then it's facing up on the next battery and facing down, because you're putting the positive, connecting the positive to the negative, and then down and positive at the bottom to the negative of the next battery, back up, positive to negative. You connect them that way to increase the voltage, to increase the energy output of the batteries, right? We add up the voltages of the individual energy of individual batteries to get more energy out of it. Okay, voltage is the energy, right? Voltage is the term that we use for the energy, electrical energy. You can see it's per charge, and I can talk about that, and we'll talk about that later. But the key idea is voltage and energy. They go together. Okay, for right now, that's the most important thing. All right. We good? Should we go to the next and last slide? Or we need another moment to get some copied?
Can you wait 1 second?
No problem.
Okay, I'm done.
Okay, we good? Everyone else? One more slide. Again, this is all just vocab stuff for this new unit. All right, so current, right? Current, I probably should have put this in different order because I went current, circuit, and back to current. Now that I look at the slide, I'll set that up kind of a stupid way. Current is the moving charges, right? It's the flow of the electrical charges. Current is the moving charges through the wires, right? The flow of electrical charge through the wires. It's moving charges through the wires, and it's the rate of flow. So current is charge per second. So if you can, as you're going through, how much charge goes through every second through our lamp in this little picture here, right? How many charges are moving through the lamp in this picture every second. It's not how fast the charges are moving. It's how many charges there are per second. Current all moves essentially the same speed. No matter how big the current is, those charges are moving the same speed. It's just a matter of how many can go in the circuit. Okay? So the unit of current is called an amp, and that's 1 amp is 1 coulomb of charge every second. Remember from our last unit, we did that conversion of how many protons and electrons, how many electrons there are. We're talking about electrons because the electrons move, right? The protons don't move. How many electrons there are in a coulomb. It was somewhere up in the order of 10 to the 20th 10 to the 20th electrons that are moving to make a coulomb. So that many electrons move every second through the circuit. Actually, just past a given point, through the lamp, through the light bulb every second, right? The next second, the same amount goes through. It's not like they pass through and then they're done, right? That same amount passes through again, right? The light bulb doesn't flash on and off when the charges come through. They're always moving, right? Okay. A circuit is the path that they're following, right? And again, I probably should have written this the other way because it always goes from positive to negative, right? In our little picture here, the long bar represents the positive for battery, and the short bar represents the negative. So it leaves the battery, that much charge leaves the battery, goes through the light bulb, comes along. In our picture, though, you can see the switch is open, so this light bulb will be turned off. You need a complete closed circuit. Here, the current can't move, so everything shuts down. You need to close the switch, so now the current can get back to the low terminal, the negative terminal, the low potential on the battery. Okay. So that's what a switch does. It opens the circuit, turns off, close the circuit, turn something on. Okay. And the final thing, you can see the final thing is the resistance. The resistance is exactly what it sounds like. Something that resists the movement of the electrons. It resists the current. The resistance, the resistor, the thing that offers resistance, is the thing that's using the electricity. So in our circuit here, the light bulb, the lamp, is the resistor. that provides resistance for our circuit. Okay. It's how much it's trying to get in the way of those moving charges and reduce the current, right? It doesn't slow the current. Oh, I'm sorry. All right, it doesn't slow the current. It doesn't make it go slower. It just reduces the amount of charge, right? Again, resistance does not slow the current. It just reduces the amount of current. It reduces the amount of charge.
Can you move the screen down a little bit? I can't see the unit, the resistance. Thank you.
You're welcome. Okay. So that's it for our notes, right? It's like I said, it's just vocab here for our unit. Okay. So tell me when we're good, and then we're going to move on to collecting the data for our assignment for the today and tomorrow. We're good here. And everyone at home okay?
Yeah,
Good?
I think.
Okay. Someone needs to say no, or else I'm going to move the camera here. Okay, I'm going to take silence, meaning we're good. Okay, so let me move the camera. Okay, so you can see my setup. Uh-oh, there we go. My wire cords mixed up here and mixed up. So we can see this. So next thing, I need you to go on Schoology. Ryan, you need to do this also. On Schoology, today's assignment, I attached a Google Doc, right, for today's assignment. So open up that Google Doc and you'll see a data table, and we're going to fill in the data table for today. All right, we got about 20 minutes, plenty of
There's no
time.
Google Doc.
There isn't? Ah,
No.
shucks. All right, I'm gonna have to stop the recording. Well, do I have to stop the recording? Probably not. Sorry about that. I apologize. I screwed that up, huh? All right, let me look at today's assignment. March 8th. Edit. You're right, I screwed up and it didn't attach to Google Doc. All right, let me do that right now here. Almost all of this. Attach. Save changes. Okay, trying to refresh it and see if it's there now.
Okay,
Yes,
yeah,
beautiful.
there is now.
All right, good. I'm sorry I screwed that up last time, but we're good now. Okay, so what we're going to look at is the relationship between voltage and current, as you can see, right? The relationship between voltage and current. Remember, voltage is the energy and the current is the amount of charges that are moving through our circuit. So here, I'm going to show you the circuit that I have set up here. This thing here is our battery. It's a power supply. The thing about this is there's a dial here and I can vary the voltage, not like regular batteries are what they are. This thing, I can vary the voltage. The red terminal here is the positive, the black terminal is the negative. So the electricity is going to flow out of the red terminal through this wire. Forgot to put the light bulb on. To the light bulb, right? Out of the light bulb through this wire, through this device right here. This device is called a multimeter, and I'm going to set it to measure current. And then out of the multimeter and back to the negative. So it's a closed switch, right? It's a closed circuit, rather. It's a closed circuit. Right now, my battery is set to 0. The volt power supply is set to 0. I have another multimeter over here that I'm going to set to voltage, and we can measure, so we can measure our current and our voltage and fill in our data tables. All right. As we go along, the other thing I want us to observe, and there's nothing to write down about this, just to make observations, is how bright the light bulb gets as we change through the circuit. And we're going to repeat that. I'm going to replace the single light bulb with a 3 light bulb system. And we'll repeat it. Okay. So it's pretty simple. I'm just going to vary the current. We'll write down the current and the voltage. And then we'll be done. All right. As I said, as we go along, we want to observe what happens to the brightness of the light bulb along the way. Okay. So let me turn everything on here. This one is my current. This one is my voltage. Okay. We're starting at 0, 0. Everything is off, right? No light at all. Okay. So as I vary the voltage, or the current here, I'm going to set the initial current. I'm going to try to set the initial current to around as close to 0.100 as I can get it. Okay, it's the current right now is at 0.099. 0.099 amps of current. And the voltage is at 1.33 volts. Okay. And you can see, I don't know if you can see, how well you can see, if you can see anything at all, but the battery or the light bulb is just the tiniest, right? Ryan can see just the tiniest amount of glow here. I don't know if you guys can see that at home or not. There's just the tiniest amount of glow in our light bulb.
Are we doing the 1 bulb?
Yes, we're doing the 1 bulb first, and then we'll repeat it for the 3 bulbs. Okay. You got your numbers here?
Yeah.
Okay. It was 0.099 for the current. And what was the number? 1.33, yes. Because I must have bumped something because it changed here on me. And I knew that what I'm looking at was different. All right, here we go. We'll move on. If I can change the current to where I want it to be. That's a little too high. Hold on. Settle. Okay. So the next current is 0.126 amps of current. 0.126 amps of current. And the voltage is 1.91. 1.91 volts. Okay. And you can see, hopefully, now you can see a little bit of glow. I can tell because I can see a little bit of glow in the picture. Right? It's starting to glow a little bit brighter, which is what you would expect. A little more voltage, a little more current would make a little more energy, so the light bulb would get a little bit brighter. Moving on. Uh-oh. Oh, okay. I was afraid I was going to burn out my light bulb. I think I bumped something and messed it up. Here we go. Next one, the current, hold on, settle. The current is 0.150, 0.150, and the voltage is 2.50. All right, and again, as we do it, you can see the light bulb is starting to get brighter.
What was the voltage again?
The voltage is 2.50. Okay. All right, there should be, if I recall how I set it up, there should be 3 spaces left on the data table. Okay. So I'm trying to go up by 0.025-ish every time for the current. Okay, sometimes it kind of bounces around a little on the meter. Here we go. Next current, 0.176. And the voltage is now 3.32. 3.32 is the voltage. 0.176 amps is the current. 3.32 volts is the voltage. Good? And again, as you see, the light bulb is now starting to get brighter. Right? We're starting to get brighter, which is, again, what you would expect, right? There's more energy, more voltage. So more energy relates to more light from the light bulb. Okay. We have 2 left to go. Trying to get it to 0.22 or 0.200. Okay, 0.201 for the current, 0.201 for the current. And the voltage is 4.22. 0.201 for the current, 4.22 for the voltage. And we have one
Sorry,
last.
could you repeat the current again?
0.201 for the current.
Okay, thanks.
Yep. And again, we're watching the light bulb get brighter and brighter and brighter, right? And finally, the last space we have, keeping our pattern up, should get us to somewhere around 0.225. See if I can get it to sit on 2.225. I did. There you go. Good way to finish. 0.225, 0.225 for the current. And the voltage is 5.25. 5.25 for the voltage. Okay, and you can see the brightness of the light bulb here at this voltage. Right? We've run out of space, but just to show you, right, I can crank the voltage up, the energy, right? The voltage is the energy. I can crank this up. I don't want to burn the light bulb out, but I can crank this up to around 12 volts and the light starts to get really, really bright. Looks like a phone light. It is a flashlight on the phone, actually. It's the same device. It's a LED light, which is what phone lights use. They use LED lights, right? It is an LED Christmas. I took my Christmas string, and when we got out of white lights on our tree a few years ago and went to colored lights on our tree. So I took the string and I cut it up, and now I have my little light bulbs. All right, so we're going to repeat the whole thing again for 3 bulbs, for a 3-bulb system, and then we'll be done for the day.
Wait, what were the voltage and the current for the last one? I missed
Oh,
that.
I moved it. So let me I'll get off Orion's here. the last one. The last one, the current was 0.225 and the voltage was 5.25.
Also, what was the first current? Because I missed that one as well.
0. Oh, I'm sorry. No, that looks, I think that doesn't make, oh, yeah, those switched. Right, right, the 0.99 would have been the current for the first one. 0.99 was the current and 1.3, what was it? 1.33 was the volts for the first one, right?
Wait, it was 0.099 for the current?
0.099, yes,
All right.
0.099. Okay? And now I'm gonna reset everything to 0 and replace the single bulb with the 3 bulb system, and we're gonna repeat it, okay? So when we repeat it, I'm gonna set the currents the same as the currents the first time, or try to as close as I can. And then we'll see the difference in the voltage and the light. Okay. So the very first one was approximately, I tried to set it at 0.1 for the current. So that's what I'm going to try to set it at again. Okay, this time I have the current is 0.101. 0.101 for the current, and the voltage is 3.63. 3.63 for the volts. Okay. Okay, so notice the first thing I want you to notice is if you compare that to the single bulb, the same current has way more voltage, right? It needs way more voltage because there's now 3 light bulbs, right? And again, you can see, I think you might be able to see how dim those 3 light bulbs are, right? Whoops, everything got turned off, a switch, my wire came undone. How much time I got? I got 5 minutes, so I got to pick up my pace here because I'm talking in between too much, right? But you can see that, right? Not very bright for 3 volts, right? The last time we ended at 3 volts with a really, really bright light with a single bulb. All right, moving on. The current was somewhere around 0.125. So I'm going to try and get it to be there again. Okay, the current is 0.125, 0.125, and the voltage is 4.8. Oh, well, hold on. 4.87. 4.87 for the voltage. 0.125, 4.87. Okay. We only have like 4 minutes left, so I'm going to make sure that I'm going to stop my commentary and make sure I get our data in. Trying to keep the same currents. Here we go. 0.150 for the current. 6.70. 6.70 for the voltage. Okay. All right. 3 more. Come on. 0.175 for the current. 9.15 for the volts. All right, and again, you're noticing way higher voltage needed for 3 light bulbs to get the same amount of current. Right? 2 left. Come on. Come on. Good. 0.200. 0.200 is my current. 11.93 is the voltage. 11.93 is the voltage. All right, again, way higher voltage. And still not as bright as the single bulb, right? And then finally, the last one. $0.225. Amani, the current before the one you asked about was 0.175. All right, the current one, the last one right now, the current is 0.225 and the voltage is 14.50. 14.50. Okay. All right, so perfect timing. We have like 1 minute left in class. No homework. Tomorrow we'll do the graphs on a Google Sheet and then answer the questions. All right, and wrap up this little investigation into current versus voltage. All right. All right, guys, have a good day. I'm going to end my recording here.
Have a good day, Mr. Shuket.
So long.